Hi everyone, let's take a look at the following example. Find the antiderivative or the integration of cotangent x with respect to x. Step number one, when you think about cotangent x, this is equal to cosine x divided by sine x. And again, the method that we're going to approach this with is called the method of substitution. So again, the concept is you want to take one part of this expression such that the derivative is a scalar multiple of the other part. So what I mean is this. If you think about one of these parts, and let's say u is the difficult part, when you find a derivative, it should give you exactly some scalar multiple of the other part. So for example, if I look at the denominator, sine x, what happens when I find the derivative of sine x? That's going to be cosine x, which is exactly there. So again, I'll say this one more time. We're going to let u be sine x because the derivative is cosine x. Now, let me also give you the opposite. It's not enough to know what to do, but you also need to understand what not to do. You don't want to say u is going to be cosine x, even though you might be thinking, well, the derivative is negative sine x. Isn't that a scalar multiple of sine x? It is, but you're not going to have negative sine x multiply by dx in a moment. So again, let me show you what I mean now. If you let u equal to sine x, this means when I find the derivative, du by dx, this is going to be equal to cosine x. So again, du by dx is going to be cosine x, which means I can isolate for cosine x times dx. So again, I'm going to bring dx to the right. So on the right-hand side, it's going to be cosine x times dx, which equals to du. Now, let me put this in a different color so you can see exactly what I'm thinking here. Right now, cosine x dx is going to be right there. And if I circle u, which is sine x, it's going to be right there. So what does that really mean? Well, if I keep going, this question now becomes the following. Instead of saying the antiderivative of cosine x dx, it's going to be du, which I'm going to put on the right. And instead of taking 1 divided by sine x, it's going to be 1 divided by u. Now again, if you think about this, you can totally find the derivative or the antiderivative of 1 divided by u. And again, that's going to be ln of the absolute value of u plus c. Remember, you're finding every single case possible. So there are infinite many cases. And again, because u equals to sine x, the final answer is going to be sine x inside the absolute value brackets. So again, it's the ln of the absolute value of sine x plus c. Now, what I would like you to try is to double check this. Spend 60 minutes to confirm you're doing it right. Now, in case you're stuck, I am going to double check this with you by telling you the actual steps. So if you pretend this is y equal to ln of sine x in absolute value brackets plus c, what happens is when you find a derivative, it's going to be 1 divided by sine x times the derivative of sine x, which is cosine x. And again, that will give you exactly cosine x divided by sine x. And of course, when you take the derivative of a constant, that's going to be 0. And that's how you know you did it right. I hope this makes sense.